Hello, sir, and everyone. My name is Nguyễn Hữu Thiện. I'm covering Group 1 today. We'll talk about the topic design and analysis of internal combustion engine, piston ring on composite material using serial ANSYS software. Uh, First, we introduce about piston. Auto part in grid demons is state due to increased yield apparent. The extreme demand is due to improve performance and reduce the cost of its component. Next, we talk about material and manufacturing process. The first one, material. The following common used for internal combustion: piston hose, gas iron, gas aluminum, gas steel, and hot aluminum. First, most of the piston use the aluminum alloy because the aluminum lightweight and it can reduce the overall mass and force of the piston. The piston ring is often made from the cast iron or stainless steel. Next, we consider about manufacturing process. Piston are usually manufactured by means of casting and forging. Um, First one, manufacturing by casting have six steps. Step one is foundering. Step two is hardening, dehorning, and canning. Step three is CNC line canning. Step four is 5-axis VMC mechanic. Step five is grinding, and last step is final inspection. And manufacturing by copy have a step. The step one, rod, screw, and the bunch. Three, the oven. Four is the wood spin hole, and oil control hole. Step five, ring growth. Step six, the milling machine. Step grinding, and the last step is finish the job.
Hello, Mr. Chang and everyone. I'm from Group 1 and I will present the problem definition and methodology and platform modeling and analysis piston design. First, factory problem definition and methodology. The design of the piston will be analyzed by finite element analysis and computer-aided design. First, finite element analysis is a simulation of physical phenomena using numerical techniques. And next, CAD methodology. Computer-aided design is the use of computer or workstation to aid in the creation, modification, analysis, and optimization of the design. CAD software also helpful in protecting products and inventions. Net platform modeling and analysis piston design. A design consideration for a piston. In designing a piston for an engine, the following points should be taken into consideration. It should have enormous strength to withstand the high pressure, minimum weight to withstand the initial forces, effective oil sealing in the cylinder, provide sufficient bearing area to prevent undue wear, has speed reciprocation without noise, and be residue for piston. To design piston, we must focus to the following parameter: thickness of piston head, the edge, head flow through the piston head edge, radial thickness of plane T1 and axial thickness of plane T2. T2 equal 0.7 meter T1 to T1. Maximum thickness of parallel T3. Y of the third plane B1. B1 equal from TS to 1.2 meter TS. Y of the plane B2. B2 between 0.75 meter T2 and T2. And the last, the piston model. The following are the sequence of steps in which the piston is modeled. Drawing a half portion of piston, existing a sketcher, developing the model, and creating a hole.
Hello teacher, my name is Trần Hạo Kiệt. I come from Group 1, and now I will talking about the robotype of materials. The result of research and development of new composite alloy piston design for internal combustion are presented in the paper. Alloy characterization test, metal graphite test, testable test, hardness test, and thermal expansion coefficient, and engine strength test as well as engine test work. And next, I will present about the structural analysis structural boundary conditions. As a basic alloy to manufacture the test sample, the near-altitude aluminum silicate alloy labeled AK12 were taken. Table show the PA12 alloy chemical compositions, a global advantage of near-altitude alloy composition, and the alloy composite, which is final result of the work carried out, and which was led to make the new piston. First PA12 alloy for the forget piston, tested composite silicon alloy, and generalized composition of near-altitude aluminum silicate alloys.
Hi sir, I'm Huy. I'm a member of Group 1. Today I'm very happy to tell you about with my part. This is the research and discussion when you use the ACID option to write and research about the piston. The first one I will introduce in the piston. The piston have the two conditions to compare. This the thesis analysis. In the thesis analysis, I will compare the two components. This aluminum component and silicon carbide reinforced zirconium dipolride component. And the next, I will introduce compare the thermal analysis. Did the second condition. The second condition to compare. Just also compare the aluminum component and the silicon carbide reinforced zirconium dipolride. In the two column, this is the total heat plate and the direction heat plate on the y-axis. The next part, this is the piston ring, and the result obtained from apply the aluminum and silicon carbide reinforced zirconium dipolride material for the piston ring are to condition like the piston. This is the thesis analysis and the thermal analysis. The thesis analysis to also compare the aluminum component, aluminum material, and silicon carbide reinforced zirconium dipolride material. Compare the total deformation, direction deformation on the y-axis and the volume trend. The piston ring in the second condition, this thermal analysis, the total heat plate and direction heat plate in the y-axis. The next part, like the piston and the piston ring, the piston ring assembly have the result obtained from the applied aluminum and the silicon carbide reinforced zirconium dipolride material of the piston ring assembly are just also to compare in the thesis analysis with the aluminum material and silicon carbide reinforced zirconium dipolride material with the total deformation, direction deformation on the y-axis and deformity trend, like the piston and the piston ring The piston assembly have the thermal analyst to compare with the two column, two different column, the total heat plate and duration heat plate in other y-axis. The last one is the model analysis. The more is the fundamental natural frequency, the more will be the deepness of the structure. The battery condition used for the model analysis is below the topping location, constrained in the on GOF as shown in the figure. The shown in the figure is the piston with aluminum alloy material and piston with the silicon carbide reinforced zirconium dipolymeric composite material. This the two column to compare the figure about the two condition to this condition. That's all in my group. Thank you for your listening and watching.
And finally, the main objective of this project is study about the reaction of silicon carbon reinforced with the zirconium diboride aluminum alloy and composite material to apply the piston, the temperature and pressure. From the results, this work concludes that the silicon carbon reinforced zirconium diboride composite piston has less deviation, while the aluminum alloy and the red iron alloy piston had more deviations. To apply the temperature and pressure, aluminum alloy have less geometrical hardness, while silicon carbon reinforced zirconium diboride piston had higher geometrical stiffness. Therefore, in order to reduce stress concentration, the piston tip must be still enough to reduce the deformation. Thanks for your listening, teacher.